Welcome to the amount of substance topic. In this chapter, we'll learn how chemists measure quantities of particles, calculate moles, and use these ideas to solve chemical problems involving reactions, gases, and solutions. Atoms and molecules are far too small to count individually. Instead, chemists use the mole, which is simply a counting unit, just like a dozen, but much larger. At a microscopic level, chemical reactions involve atoms, molecules, and ions reacting in fixed ratios, but these particles are far too small to count directly. The mole bridges this gap by linking measurable quantities to numbers of particles. Relative atomic mass, R, is defined as the weighted mean mass of an atom of an element compared with 1/12 of the mass of a carbon-12 atom. The term weighted mean is crucial because most elements exist as mixtures of isotopes, each with a different mass and natural abundance. Molar mass is the mass of 1 mole of a substance. It is measured in grams per mole and is calculated by adding together the relative atomic masses from the periodic table. Relative molecular mass, MR, is defined as the sum of the relative atomic masses of all atoms present in a molecule. Like R, MR is a ratio and therefore has no units. Students calculate MR by adding together the R values for each atom shown in the chemical formula. The mole is the SI unit for amount of substance and is defined as the amount of substance containing exactly 6.022 times 10 squared cubed specified particles. This number is known as the Avogadro constant and has units of mole to the power of 1. The mole links directly to molar mass. 1 mole of a substance has a mass in grams equal to its MR. One of the most frequently used equations in chemistry is N equals m, where N is the amount in moles, m is the mass in grams, and m is the molar mass in g mole to the power of 1. This relationship allows chemists to convert a measurable mass into an amount of substance, which can then be used in further calculations. Concentration calculations in solutions, the ideal gas equation and gas calculations, graphical relationship between moles and gas volume. Concentration is defined as the amount of solute dissolved per unit volume of solution, usually expressed in mole dm cubed. The key equations are C equals NV and N equals CV, where N is moles and V is volume in dm cubed. The ideal gas equation, PV equals nRT, relates pressure, volume, temperature, and amount of gas. Pressure in pascals, volume in cubic meters, temperature in Kelvin, and R equals 8.31 J K to the power of 1 mole to the power of 1. Converting units correctly is critical. For example, volumes given in dm cubed must be converted to cubic meter by dividing by 1000, and temperatures in degrees Celsius must be converted to Kelvin by adding 273. At constant temperature and pressure, the volume of a gas is directly proportional to the number of moles present. This relationship can be shown graphically as a straight line through the origin when volume is plotted against moles. Such graphs reinforce the conceptual meaning of the mole and support understanding of both the ideal gas equation and molar gas volume approximations. Empirical and molecular formula determination, balanced equations, and reacting mass calculations, percentage yield and atom economy in industry. The empirical formula shows the simplest whole number ratio of atoms of each element in a compound, while the molecular formula shows the actual number of atoms present in one molecule. Balanced chemical equations show the mole ratios in which reactants combine and products form. Reacting mass calculations typically follow a sequence. Convert a known mass to moles, use the mole ratio from the balanced equation, then convert the resulting moles into a mass or volume as required. Percentage yield and atom economy are measures of efficiency in chemical reactions. Percentage yield compares the actual mass of product obtained with the theoretical maximum, using the formula actual yield divided by theoretical yield times 100. Yields are often less than 100% due to incomplete reactions, side reactions, or product losses during purification. Atom economy measures how well atoms in the reactants are converted into the desired product, calculated as MR of desired product divided by total MR of reactants times 100. A high atom economy indicates minimal waste, which is desirable for economic and environmental reasons. Worked exam-style calculation and common pitfalls. Summary of key equations and revision tips. A typical exam question on amount of substance may combine several ideas, such as mass to mole conversion, mole ratios, and percentage yield. For example, students might calculate the mass of product formed from a given mass of reactant and then determine the percentage yield using experimental data. The correct approach is always methodical. Write the balanced equation, calculate moles, apply ratios, and convert to the required quantity. Always write down the correct formula, include units, convert volumes carefully, and check that your balanced equation is correct before starting calculations. You've now covered the key ideas in amount of substance, including moles, molar mass, reacting quantities, gases, and solutions. Mastering these calculations will provide a strong foundation for the rest of A-level chemistry. Thank you for watching.